Hey Chem Kids, this is Underwood coming at you with another Honors Chemistry webcast. Today our topic is going to be empirical and molecular formulas. Before we start talking about empirical and molecular formulas, I need to explain to you a new concept, and that's the concept of the mole. Remember in class when I told you that we were going to be dealing with very large numbers of very small things? Well, the mole is a unit that actually makes it just a little bit easier for us to deal with those large numbers. 1 mole is equal to 6.02 times 10 to the 23rd of anything. So if I had a mole of elephants, then I'd have 6.02 times 10 to the 23rd elephants. If I had a mole of pennies, not only would I be rich, but I'd have 6.02 times 10 to the 23rd pennies. If I had a mole of spiders, then I'd have 6.02 times 10 to the 23rd spiders. You guys get the idea. Now, in chemistry, the mole is used mostly to denote 6.02 times 10 to the 23rd atoms or molecules. Those are the particles that we're dealing with the most. Now, on the periodic table, it gives us the atomic mass of elements. And up until this point, you guys have been using atomic mass units. Well, right now I want you guys to forget atomic mass units and understand these new units for atomic mass, grams per mole. So if I was to look at something like carbon, and here's carbon right here, it says that I have a atomic mass of 12.01. And in the past, you guys have used atomic mass units. Well, no more. Now we use grams per mole. So what this says is that 1 mole of carbon has a mass of 12.01 grams of carbon. And we call this relationship here an equality. Now we could turn this equality then into what we call a conversion factor. So we can say 12.01 grams of carbon per 1 mole of carbon, or we can say 1 mole of carbon over 12.01 grams of carbon. Those are what we call conversion factors. And on the next slide, I'm going to teach you how to use them a little bit. So let's do a quick example here. Let's say that we had 24.02 grams of carbon. Now, let's say I asked you, well, if I have 24.02 grams of carbon, how many moles of carbon do I have? Well, all you'd have to do is multiply that by a conversion factor. And the conversion factor is going to have the grams of carbon on the bottom and the moles of carbon on top. And this is so you can cancel out these units and be left with moles of carbon. This is how we solve. Now, with our conversion factor that we found from the periodic table, we know that 1 mole is equivalent to 12.01 grams of carbon. When I do this math, I find out that 24.02 grams of carbon is equivalent to 24.02 divided by 12.01. That gives us 2 moles of carbon. So that's how we would use our conversion factor. So now we can talk about the empirical and molecular formulas. The empirical formula is the most simplified formula for a given compound. Let's take, for example, this here. N, nitrogen, and oxygen. Okay, 1-to-1 ratio, very simple. Now, from this empirical formula, we can derive a number of different molecular formulas. There's molecular formulas like N2O2. So you see how the empirical formula is just a simplified version of the molecular formula. The molecular formula actually telling us how many atoms of each element there are present in 1 molecule of that specific compound. Now, given certain problems, I can go ahead and solve for both of these. let's go ahead and start out with something that's a little bit more simple. Calculate the empirical formula for the following. A compound containing 75% carbon and 25% hydrogen. This is the type of data that I'm going to give you guys when I'm asking you to solve for these problems. So if we look at it, the first thing you guys want to do is you want to assume, you want to assume that you have 100 grams of a given compound. So in assuming that, we can turn these percentages, 75%, into 75.0 grams and carbon, and we can convert the 25% hydrogen into 25.0 grams of hydrogen. Now, see how I just converted those percentages into gram form by making the assumption that I had 100 grams of this original compound? Now I need to go ahead and convert these two numbers to moles. So I multiply these by the conversion factors. If I look on the periodic table, I know that 1 mole of carbon is equivalent to 12.01 grams of carbon. My grams cancel out, and when I complete this calculation, I find that I have 6.24 moles of carbon. Now I do the same thing for hydrogen, but I have to make sure I pay attention to the periodic table because hydrogen is going to have a different atomic mass. It has an atomic mass that is equivalent to 1 mole of hydrogen over 1.01 grams of hydrogen. Now taking the 25 grams divided by 1.01, my grams of hydrogen cancel out, and I'm left with 24.75 moles of hydrogen. So first step, convert those grams that I got from the percentages into moles. The next step is this. I divide each of these by the smallest number of moles that I've calculated. Now when I do 6.24 divided by 6.24, I get a number that is equivalent to 1. When I do 24.75 divided by 6.24, I get a number that is, ends up being about 4. So then I can look, okay, I had 2 elements in this compound. I had carbon, which has a coefficient of 1, and I had hydrogen, that has a coefficient of 4. So here is my empirical formula.